Hello students, or cosmonauts. If you're looking at the web quest, you'll see that the actual challenge of this problem is you are stuck on a space station out a zillion miles from Earth. Don't worry about the equation of balancing a zillion miles. The bottom line is that you're on a space station and you're trying to get back home to Earth using your rocket ship. Your rocket ship is propelled using propane burning in the presence of oxygen. The reason that you would want to use a fuel like that is because it gives off two very useful things for cosmonauts or astronauts that are on long journeys. Engineers figured this out. Propane, or C3H8, burning with oxygen renders carbon dioxide and water. These are things that plants need. And if you have plants, plants give off oxygen that keeps astronauts alive. So that's why it's designed that way. So your challenge is figuring out the proportion of propane to oxygen you need to have, because necessarily a rocket ship's only going to have so much space on board. But you have to know how much of each element, or each, chemical to actually take with you. So, three simple steps to basically balancing an equation. So we're going to balance propane with oxygen, resulting with carbon dioxide and water. Step one, write it down. A lot of people make this error. So propane, for example, has 3 carbons with 8 hydrogens. It's a fairly basic hydrocarbon. With oxygen, oxygen in its most basic state resides with 2 oxygens. They like floating around that way. They connect together. Just how it is. Carbon dioxide, CO2. You guys, of course, you've heard of CO2. And water. All living things love water. Step 2, write down what you have. So on this side, you have things called the reactants. The reactants are like the stuff on one side of an equation, which is going to result in something else. These are your products. That's what's resulted from it. So this is an assembly line. This is what comes out of it, your products of the assembly line. So we have 3 different elements that are present in this equation: carbon, hydrogen, and oxygen. A technique, and do this. If you have hydrogen or oxygen in any of your equations, always do them last. You don't have to, but it'll save you a lot of pains in the neck because it's just easier to balance them that way. Physicists and scientists and chemists have figured this out over eons. It seems to work, so just do it that way. So we list them as reactants, things on this side of our balanced equation indicator, and products. So we have 3 carbons as reactants and 1 carbon on the product side as products. For hydrogen, we have 8 present, 8 atoms, and we have 2 hydrogen atoms on the product side. And finally, for oxygen, we have 2 with the reactants, and we have 3, 1, 2, and 3 over in the products. If you ever get confused about that, you see the little number to the lower right-hand side of any of these atoms. That's called a subscript. And what that does is that annotates how many atoms are present. What we're trying to figure out is what goes in front of each of these molecules, a molecule being several atoms together. That's called a coefficient. And that is how you balance an equation. So, the third step is determining how much of each of these molecules there needs to be to make it balance. Isaac Newton came up with the whole idea of continuity of matter and mass, and this is why we always have to have balanced equations. Otherwise, it just doesn't work. Alright, so we'll start off with carbon. So on this side, we have 3 carbon atoms within this molecule. Just focus on it being carbon. Over here, we only have 1. So very simply, 1 times 3 equals 3. So we have to put a coefficient in front of the carbon there, so 3. Now, what has just happened is even though we've balanced carbon, we've imbalanced some of the oxygen, because 3 times 2 equals 6. So we have to annotate that down here with oxygen. Sorry, I pointed to hydrogen, I meant oxygen. So here we had 3 before. We have to change that to 6 plus that one, so there's 7 right there. You want to keep doing this kind of annotation the whole time, and it helps you to follow where you're going. So now we have balanced carbon. Next we're going to go to hydrogen. We have 8 hydrogens. Over here we have 2 in the products. So we have to do something to make the products balance with the reactants. Well, easy again. We change the coefficient. If I did have just one water molecule there before, in order to make 2 times what equals 8? 4. Now, that equals 8. 8 products, 8 reactants. However, this also affects our oxygen. So we have to change this down here. So 3 times 2 is 6. 4 times 1, and when I'm referring to the oxygen right here, 4 times 1 oxygen is 4. So now we've balanced carbon, we've balanced hydrogen, but oxygen is still out of balance. So we go to our last element, oxygen. So over here on the product side, we have 10 oxygen atoms. So we go over to the reactants. What times 2 equals 10? 5, of course. So this becomes a balanced equation. You now know that your ratio of propane to oxygen is going to be 1 to 5. And you can use that information to determine how much of each chemical you need to put in your rocket ship. Safe travels. Good luck.